And so what happens when there's two terms in the denominator? Bless you. Okay, so the idea is if you have two terms and either one or both of the terms contain a radical, what you're going to need to do is follow these three steps here to make sure that the radicals are completely removed from the denominator. That's one of the conditions for a fraction or a radical to be simplest form, is there can be no radical in the denominator and no fraction within a radical. And so the first step on these is to simplify all radicals in the problem. For the most part, what this means is if there's any perfect square factors you can remove from the radical, remove it. You want to simplify the individual radicals completely before you move on to the next step. And so in this process, or in this problem right here, root 7, there's no way to simplify that. It's already met all the criteria for being the simplest form of a radical. And so then you move to the step where you rationalize. And the process of rationalizing a double term denominator is the following. You're going to multiply the numerator and denominator by the conjugate of the denominator. And so let's see what that means. What that means is if your original expression was a plus b root m, then the conjugate is going to be the exact same two terms, so a and b root m, and just the opposite sign between them. Okay, so what that means is, let's say you had a root m minus b root n. Again, it can be one term has a radical, or they can both have a radical. The conjugate is simply going to be same two terms, so a root m and b root n, opposite sign between. So there was a negative here, so this changes to a plus. So that's how you identify conjugates. So when we go through and rationalize this problem, we're going to multiply the top and bottom by the same terms, 3 and root 7. We simply change the sign between the terms. Notice we're not changing each term, the sign of each term. We're changing only the sign between them. Okay, so it was the sum of these terms in the denominator. We want to change it to the difference. And now the whole reason that we do that is it's based on the idea that in order for us to get rid of the radicals in the denominator, we're using the process of multiplying the sum and difference of terms together. Because when you FOIL these, the outer and inner products are exact opposites of each other, so they cancel out. And that leaves, again, when you FOIL, an a squared, the square of the first terms, always minus the square of the last term. And so by canceling the outer and inner products, that's going to get rid of all the terms that contain a radical, and it'll just leave the non-square roots as your values. Okay, so this process, when we actually go through and we rationalize this and multiply across the top, we get 2 times 3 minus root 7 all over. And again, if we follow this process, it's always just going to equal the difference of the squares of the terms in the denominator. So we get 3 squared minus root 7 squared. And that's always going to be true. And so our final step in this then would be to simplify the resulting expression. And so if we simplified up here, now in the process of simplifying, I would encourage you, do not expand your factors in the numerator. You don't need to distribute that 2 through. If you do, it's not going to be marked wrong. However, there's 2 reasons not to. Okay, first reason is anytime you add steps that aren't necessary, and I've just told you it's not necessary, you add the possibility of making a careless mistake. And so when students distribute, there's always mistakes, especially if there's a negative sign involved. And so the fact that you don't need to simplify it or expand it means just leave it as factors. You'll eliminate the possibility of making that careless mistake. The other thing that it does is in this process of simplifying, it's already in a form that's more conducive to canceling common factors, which may or may not happen in the simplified process. So by leaving it in this form, you don't have to go back and try to factor it out and cancel common factors. And you're going to see that here in a couple of these examples of why you want to keep it written as factors. Okay, so if we continue to simplify this, the 3 squared is 9, root 7 squared is just 7. And if we continue to simplify, 2 times 3 minus root 7, and what is 9 minus 7? So here's the case, that in the simplifying process, these factors can cancel, and we're left with our answer, 3 minus root 7. Okay. So once again, in this process of simplifying, always just leave everything written as factors. And even when you get into working with rational expressions and rational functions where you're graphing them, you'll leave all your values in factors anyway because it gives you useful information about the graph as well. Okay, so there's no reason to expand your factors on this.